folks, I'm going to share basically my screen, and you should be able to see it. Yep. Yep. Okay. Do you see my screen?
Yes, yes.
Okay, cool, excellent. So basically, the program today, we are revising day by day a little bit the program according to the inputs that we get from you guys, and so we decided initially was meant to be just a quick introduction, but we are going to have 1 hour today after my the first hour dedicated to flood simulation analysis. I think this is a kind of issue in Idlib operation as well, so this is kind of important. Regarding the first part of this session, we're going to talk about these emergency settlement structures. So how basically they are made. I presume that did you have the chance to have a look on the UNHCR emergency handbook, which has been placed in Dropbox? Did you read it?
I had a look.
Okay, Rawan, I know that you are a technician, a designer. I guess you were familiar with this kind of documents. Are you?
Can you hear me?
Yes, now I can.
Yeah, actually, I used to work using these documents with UNHCR in Zater camp. So yeah, I have an idea about it, the emergency logbook, the book, and the sphere book.
Okay, okay. And Khalil as well?
Yeah, yeah.
Okay.
I don't remember if it is because I looked a lot. I don't know if this is what you are talking about.
Okay, no problem, no problem. But if you go to your in the Dropbox folder, we keep updated this Dropbox folder, and where you can find kind of a lot of things. I have personally decided to add one folder. This is for very for the people are in charge of designing the emergency settlements, and which is called CAD, which is called CAD recommended. And I have noticed that when I receive DWG files from Syria, they are completely messy in terms of naming the layer. Okay, this is very important for those that are very much focused on the designing of the camps. They directly design the camps. I recommend to have a look at these documents, who are kind of international standards for proper layering with the CAD drawing. If you are not familiar with it, just have a look, and we might come back on this one because it's very important, particularly when you exchange files with your technical colleagues. It's important to give them a file that can be easily and clearly read. That's very important. You have also a CAD layer, a simplified version that might be useful. So particularly, I was referring to this document over here, which is the emergency handbook of UNHCR, and of course the sphere standard. As I said, here you basically find the key points that you might need for your job. And also here there is an Excel file, which is a very quick recap of aspects that you have to have a look when you design an emergency settlements. And then you have to decide which of them are necessary, are important for your settlement. But as you can see here, you have healthcare, water, sanitation, solid waste, shelter, fire breaks, sites in general, and then typical service infrastructure. So it's just a very simple file, but you can get a lot of information on that. Okie dokie. We go back to the presentation of today, which is, again, we are going to face the aspect of design. And now we have to understand basically how the settlement frameworks and components of every settlement that we are going to design. Basically, in this slide, and you can have a look on basically how an emergency settlement is composed and the structure. I mean, on the left side, I mean, let's start from the right side. I mean, because normally as a common practice, we design emergency settle by modules, and these modules and that starts from the family plot, and then the community over here you can see on the right side of the screen, which is a cluster of family plots, and then you have the block, which is a cluster of community. And if the camp is very big, you have sectors which are cluster of blocks. But I mean, within this structure, you have a series of components which are, all of them must be designed. And that's the point. I mean, too often I see designs of emergency settlement that just take in consideration the structures, but they don't detail all the other elements. All these elements has to be detailed as precisely as the structure. So, for example, we have a water and sanitation component, which is the drainage network, very important. I have seen drawings where the level of definition was not enough detail. This is very important. The sewage network, the water and sanitation, how are you going to do that? If there is going to be a waste treatment system or a waste dumping spot, and then the health structures, if any, of course, depends on the complexity of the camp itself. And all of this is basically related to water and sanitation and health, which are very, very connected. And then we have in green that can be all the open areas, the green areas, the lighting system, the school facilities, the child-friendly space, and the community centers. Because all of these, I mean, if you group these components, you will see that the first one are related to health. The second one is related to protection. I mean, protection colleagues will insist on you as a site planner whether you are taking into account these elements and whether you are designing them properly. This is very important. And then we have
the first one is related to what you said?
The first one is related to health.
Health. Huh?
Okay. Water and sanitation is very much linked with the health. Of course, people have to drink the water, but you have also to get rid properly of the black waters and the gray waters. So the sewage system, and particularly the water treatment plant that you put in place in your camp as fundamentals. Whether you go for cesspools, you go for septic tanks, you go for kind of simple water treatment plant. By the way, I know that Rawan, Khalil, and Khaled, you all are technician, right?
Yeah, for me.
Okay. Do you know what the HEMOF tank is? HEMOF?
Sorry, the what?
Do you know what the HEMOF tank is? EMOF. I would just remind me this because might be an option sometimes for the treatment of black water in confined settlements. But we will talk about that perhaps later. And then when I was saying here, those lighted in green are related to protection. Then we have a component which is camp management, which is important as well, because it affects somehow your design. We have seen this yesterday. And also you have space for store space, logistics, warehouses, whatever you might need. And the last but not least is the fire prevention, mitigation, and firefighting system. I mean, I mean, there is a difference between fire prevention, fire mitigation, and firefighting. Okay, fire prevention is the system that you put in place to avoid fire. The fire mitigation is the system that you put in place to mitigate the effect of the fire. And then there is the firefighting, which is the system that you put in place, I mean, to counteract if the huge fire is happening. Okay. I mean, we might have an entire lesson on this one. It's a very, very important component of your design. Okay, so basically those are the modules that we have to deal with. I mean, basically, as you can see, we have modules that start from the family module and go up to the settlement itself. I mean, the first one, the family module, which is a structure for one family, I mean, might have a dimension for 4 to 6 persons. This is the only one that we have to refer to precise standards, like the sphere standards. So we might have 3.5 square meter per person, and this is a standard that we shouldn't go below.
Doctor, sorry to interrupt. I think for Syria, we count with 6 family. Sorry, with 6 person. Please correct me, colleagues, if I am wrong.
Okay.
So now it was changed to 5.
Yeah.
Now it's back to 5 again. Okay.
5.
Good, fine.
Okay. All the others, community, block, sector, and settlement, is just, let's take it as a major indication. It doesn't necessarily mean that you have to make a community with 16 families with the 16 family plots and for 80 persons, as well for the blocks, as well for the sector and the settlement itself. Normally, if we refer to UNHCR standards, it is recommended not to make settlements that are bigger than 20,000 people. This is understandable because bigger is the population. I mean, the complexity that you have to deal with might overcome the resources that you have. But definitely this doesn't happen very often, because in every single settlement I have designed in my life, we were far bigger numbers than here. I mean, the only positive side that I'm noticing for the Idlib operation, that the settlement are pretty small, and this is a great advantage from a site planning perspective. So again, take this data as an indicative data, but you don't have to comply with it. The first one, yes.
What about the community? What do you mean by community inside the settlement?
Okay.
The family is the tent, so community is what in this case?
The community is a cluster of family plots. It's a cluster of tents, which are organized within a community. But we are going to look at it right now. Okay. Okay. And if it's at the end it's not clear, please come back and ask me again. Okay. I literally love when you make a question, guys. Please interrupt me. You have the chance to do it. We are just few, so just shoot your questions. So this is something that I would like you to think about. It's a very simple scheme. Okay. From here we have the family plot. Okay. And inside we have the tents. Okay. It seems quite easy to do. This one specifically, this is a tent of, I didn't put the dimension, but the point for me is to talk about the structure. So the family plot, it might look like a simple unit, but it's not. It is the brick, is the thing, the brick of your settlement, the very first step that you have to think about. For example, this one in particular, this is was thought to be a 20 square meter tent in a 60 square meter plot. Okay, which is kind of good according to sphere standard, because sphere standards recommend to have at least the family plot should be at least 2 times the size of the tent, of the shelter itself. I think it's if you apply these standards, you have a very small family plot, and it's always important when you make your design. I mean, as you can see, indicate in your shape where you have the entrance of the tents. This is important because it depends whether around you have other tents of the road, but this can give you an indication. But if we continue, something is happening because you have to make the pitching of the tent. And you should be able to know how wide this pitching is. Sometimes it can be up to 1.5 meters, sometimes even longer, not necessary. But as you can see, if I take in consideration the pitching, I mean, the shape of my family plot is changing. I see one that you are laughing, you're smiling. What are you thinking that? You unmute. Okay.
Yeah, I'm sorry, but like they're ordering like the food and want me to join them. So I told them that I'm
Ah,
in
okay.
training.
No, that's
Sorry.
okay. No, no, it's okay. Sorry, Rawan. I thought it was
Don't
because
worry.
of for the presentation.
No,
Sorry,
no,
sorry,
I'm
sorry.
sorry. It's my
Okay.
fault. Yeah.
So basically, going back to the pitching, you can notice that if we take in consideration the pitching, I mean, the leftover space is not that much. Probably you have some in the front, in the back, and which are positioned that we are not there. There is no pitching that is supposed to take place over here. So the big people have to go inside, but the leftover space is very limited. And then you might see whether you might need space for cooking and resting. Normally, they do it next to the front door of the tent, and so they might have a corner that they utilize for cooking activity, and they might utilize another part of the family plot corner just to rest, to put some chairs, to stay outside during daytime. So also by looking at this very simple scheme, you might understand that the space that they have available is very limited. So the people living in an emergency settlement really needs open space that they can utilize, because what they have in their own plot is very limited. And of course, if you imagine a settlement in which you have family plots next to each other, the dimension of the tents and the pitching, you might realize that that there might be spaces that cannot be comfortably utilized, because sometimes it might be difficult to go back here, and sometimes on the back, I call it backyard of the tent, if I may use this term, you have kind of I mean dumping spots, because people start to collect stuff over here. Not always, but it may happen. So there is not that much that you can do to avoid this one, but just take in consideration. That's definitely important. And then we have, I mean, which is very important to me, and the family plot, it's not a static element of your design. It might change over the time, but you might try to guide, or at least to give a direction to this change. So as you can see, we have already seen this slide the first day of this training. And as you can see here, you have your tent, and you might think that one day your settlement, the tent shelter will turn into hard shelters, and as such you might think to build walls. So this is a kind of plan that we were discussing whether it was feasible. So you save a little bit space for gardening, and you have a 2 rooms building plus a kitchen and a kind of storeroom that connect to your new family latrines. So, but this might change over the time, and you might not have the control, because very often IDP or refugee families, they build on their own, um, but instead to have your emergency settlement transform into an informal settlement, you might try to see how to give a direction to this change. If I want them to have this shape because I believe it's the best shape possible according to the family plot, because it's the most efficient. They have open air, they have hardcore shelters, they have a kitchen, they have a file, they can do gardening. How can I guide them to do that in perspective? Guys, any thought?
Sorry, in this picture, where is the tent here?
Okay, the 10 is this one, the green dashed line.
Okay.
But this is in perspective of a transformation of your settlement, because should the settlement become more permanent and the people are shifting from a tent shelter, a soft skin shelter, to a harder, a concrete shelter, a cement shelters, so you should be trying to avoid the settlement itself to become an informal settlement where there is no control.
So people are removing the tent and putting and building these.
It might be an option. I mean,
Yeah.
depends of the policy, depends what's going on in that specific operation. For example, I was working in countries where there were initiatives called tent-free initiatives, which was to get rid of the tent because the displacement was lasting much longer than expected. Again, and then we
Yeah.
go back to the lifespan of a settlement. If the lifespan is very long, years, you cannot count on tents anymore because they get ruined in 1 year of time. And so you have to find
Yeah.
alternative solutions.
Yeah, that's correct. Actually, we have like these cases in Azaz camps. It is for more than 5 years ago established it. Now they shifted from the tents or caravans to the cement walls, and you can call it now like a village. It is not a camp. If you go to Azaz camps, and you will see a village, not a camp.
Yeah, totally. I mean, this is absolutely very, very appropriate. In any emergency settlement, this happens very often, very, very often. But I will show you some slides when we will talk about the next Monday, next Tuesday. There will be a specific lesson, a session on future of camps. But this is to say that we might start thinking when we design our family plot, in case might happen, you might have a kind of prediction, a vision on a scenario that what's going to happen when you will move from a tent to a concrete shelters. But I mean to give a positive direction to this change, I mean from tent to cement shelter is not easy because sometimes you cannot put in place rules that the inhabitants should comply with. So my question for you, Khalid, that you have experience, how can you guide this change in a positive way without, giving them, the best available space for living? I mean, keeping sufficient health condition, for example, illumination in the room, air circulation, insulation, protection with the climate. You get my point. There are many issues
Yeah, yeah.
that you have to face.
Yes, you are right. But look, this should be from the beginning. When you start to plan for the new camp, you need to put in your consideration all these aspects that you are talking about. So from the beginning, you need to be sure there is available space. There is a plot, family plot. As you mentioned, it should be twice, double the tent space. For any extension in the future, they have their space. They will not do any harm to their neighbors, and already this space allocated for them. How we can guide them? Of course, we can. Since we are working in the camps, or any NGO still working in the camps, and even the camp management should have stricted guidance to not do any harm to their neighbors. Maybe they will do some extension to their plot or tent, but this extension maybe will avoid the sunlight for their neighbors. Or
Indeed.
maybe they will do some improper, maybe they will do some maintenance or some sewage system for their tent, but they will do harm for their neighbors, or maybe they will affect the roads or make a swamp. And so the camp management here will play a main role to guide the beneficiary. How can they invest their space in a proper way?
Yeah, indeed. I totally understand. Any other thought?
Yeah, like I have a question. So this is a standard design for building or a shelter, but I think it depends on the total number of beneficiaries or total number of or the size of the family in the shelter. So for example, if we have 13 persons living in one family, as a one family, it will be different than 5 family members, if that makes any sense.
It does. No, it does.
So I can see there's 2 rooms in this shelter, but how can we make sure like how many members in one room per one room, or how many rooms do we need for more than 13 persons family?
Okay, Rawan, I get your point. First, I want to clarify that this is not a standard. This is not a model. This is just a scheme that I'm using to launch this discussion. So you will have to develop, if you will have to face this problem, your own model, and in a way that try to respond even issues of overcrowding. I quote to you a sample. In Iraq, we were discussing about the opportunity to add one floor. So you have the ground floor and you have the first floor. I was personally in agreement with that, even if there are some kind of technical implications that you need to be sure to overcome properly, because you might need the bearing structure properly designed and executed. And very often, this kind of transformation is in the hands of the inhabitants, self-constructions. There is no company making the building for them. So despite the challenges, I was very much in favor to rise the level, the highness of the settlement itself, because you cannot occupy every single free space. So I was in favor, and there was a huge battle, but I lost because of the government and local authorities, camp management, protection colleagues, everybody were scared. Oh, these buildings are going to collapse. Oh my goodness, no, we cannot do it. I think we can. I think we can. And I mean, I have learned a lot from an Egyptian architect. His name was Hassan Fatih. I don't know whether you know this guy. Guys, you should be knowing. He's one of the most important architects ever. But unfortunately, when we go to the university, they overload us with Le Corbusier, Frank Lloyd Wright, all these kind of fancy architects. But we should be looking to architects with soul. Hassan Fatih was an Egyptian architect that built an amazing book, which is Building for People. I suggest you to have a look at it. Hassan Fatih. Maybe I can put it in the chat.
Yeah, please. Yeah, please.
Let me.
Yeah.
Okay.
Hassan Fatih.
Yeah, you have it.
Fatih.
Guy. This.
Fatih.
Okay. How can I put it in the chat? Where is chat? What is chat? I stopped sharing so I can use the chat.
Giorgio, go ahead with your presentation. I will do that.
No, I just did it. Okay, share screen, back. Okay. Okay. This is to say that we have, in my opinion, we should be given the opportunity that the settlement to evolve, even if we have to take some challenges. For example, if you don't have a road wide enough, you will never have the chance to put at least the family toilet on the road. So you will be forced to use part of the space inside. This means additional overcrowding. I think there is no one answer for this. There is no one, at least. I personally believe that this is mostly a matter to deal and to work together with the people living there. So there is the social component that we have to work on it.
Actually, in Azaz, as my colleague said, and in Turkish areas, the Turkish administered areas, they encourage building walls, like instead of tents, they put walls of blocks, and then they cover them with shader or plastic sheet.
Yeah.
Now
so we are.
Is a great idea, I think, but I wonder why don't the cluster encourage this? They don't encourage this thing.
Yeah.
Although it's more efficient and more durable.
Yes, let me update you about this topic. Actually, now we are implementing some cement walls shelter. The roof will be plastic sheet, and added to that, the cluster now start to advocate about this modality, and there is a technical working group established for this to discuss this topic with Alexander. and some NGOs now. And tomorrow there is a second meeting to agree about the design, the BOQ, and the cost. Then that type of modality will be, it will be a challenge related to the HLB issues, because it will be like of durable solution, and the landowner and a lot of problem related to HLB issues. For that, it is not publicly adapted. Many
But as long
challenges.
as we have the approval of the owner, and every HLB issue is done, due diligence and everything. So I think there is no
you will face cost challenge. We will talk later, and I think the shelter will release this through the emails to all the partners. You will be aware about that.
Great news. Okay, thanks.
Okay. Guys, if you Google, if you search in the web the concept of incremental shelter, you will find quite a lot. It's a way to, unfortunately, this is not a shelter and training, so I have to be very much focused on the site planning. But if you want a site, you can contact me. We can talk about the concept and how to implement the process of incremental shelter. Okay, so better we continue because we are a little bit running out of space. This is the community I was talking about, Mohammed. For example, the community is an organized group of family plots, okay? And this is a typical block layout plan. Each block contains 20 tents and 2 wash areas, which are separated, by the way. So in this case, you can see this community layout has 20 family tents in an area of 30 times 50 meters.
Sorry, Giorgio, I think it's a mistake there. It's a community layout, not a block layout.
Yeah, it's a community layout.
But you wrote typical block layout.
Yeah, but this is the mistake of the of this one, which I got from a cluster document. But this is a community.
Okay, just to be clear that it's a community.
Yeah. I'm sorry. Good point. I will correct it. But this is a typical community layout plan. This is a mistake of the subtitle over here. I will correct it. So, but this is a community. So, as you can see, the wash facilities there are communal spaces in the middle. And the distance between tents is 2 meters. Is it okay? Is it satisfactory in your opinion? Just quickly, what do you think? Okay, I will respond for you. This is what the cluster said about this layout when it was approved in Iraq years ago. This spacing is very limited. It does not allow for significant future expansion around tents. The shelter and CCCM cluster agreed to this solution due to space constraints. Okay, this is to say that probably if this settlement will move into a transformation, say, having this kind of community so tight will be very difficult. So, but sometimes you have to accept the fact that you have to accommodate such a large number of people in such a small space that you have to find compromises. Even the willingness of the road 7 meters is not enough, in my opinion, at least for the main roads.
Giorgio, can I intervene?
Yes, please.
In my experience, when you have to download, to open a new site, you discuss the layout of the community with the authority, with the NGOs. And as a site planner, I tend to go for the health and for the welfare of the refugees. That's why I try to go big. Let's say, I say always, now I need at least 4 meters of space between tents, knowing that it's big, but then I will start to negotiate from 4 meters. At the end, I go down to 3. But if you start to negotiate at 2 meters, you cannot go down to 1 meter. So at the end, I try to go big, and I make big road, I make big space, and I negotiate down.
Well done, Andrea. You are a trader. You're not a site planner.
Yeah, but I do the layout for the people. Not for...
No, of course, I agree.
Trick.
No, well done. Okay, community. I just want to show you a community section which is related to this community over here, this kind of organization. And this is, as you can see, I mean, that there is the section of the road, you have the different layers, you have a drainage, you have a gap so that to prevent the flooding and anything, you have internal path, because this kind of tent allowed to do that because there is no pitching for this type of tent, okay? But for the type of tent that you have the pitching, you have to take in consideration the space, whether you have enough space to allow internal walking. But then again, any critical points for this kind of section? Just quickly, from a pure technical perspective over here.
I think the trenches, maybe. There's a lot of trenches between the tents.
I mean, you're talking about this drainage
Yeah.
here, trenches? Yeah, might be a point, definitely. I agree with you, Rawan. It might be a point. I mean, it's good to have the infrastructures, but then you have to maintenance them. Any other thought? It's better we go a little bit. Go ahead, please.
Just we are looking now.
Just one. Yeah.
Yes. Go ahead.
I was thinking about the elevation between.
Elevation between? Rawan? Can you hear me?
Me?
Now I can hear you.
Now you can hear me?
Yes, I can.
So I think about the elevation between the ground level and the road level. Yeah, it's good to have elevation, but I think it's like 30 centimeters is.
It's not enough, perhaps. Okay.
Maybe, yeah.
Okay.
And even the space between the tent and the trench, it is maybe affected by any floods. And I'm asking why there is two trench between the tents.
Okay,
this trench from this side and trench from this side. Why everyone? I don't know. This is based in the situation at the ground. How this will run out of the.
Okay, there might be a point to have these trenches, because if there are sudden heavy rains, you might, despite you have your community which is higher than the road, you might have temporary kind of a swamp all around. So this helps to minimize the problem. So I'm not against in principle, but if you have a good slope here, a general slope of the community, you might not need these trenches, or you might need the trenches, just the one that are higher than the other side. But you are right, guys, because those are basically the critical points, because they might be working for a limited amount of time. But if you don't have proper confinement, the erosion over the days and over the weeks, sooner or later will spoil this kind of solutions. You get my point? So I know that it's an emergency settlement. I know that we have very limited resources, but we cannot avoid thinking about even the cost implication for the maintenance. So sometimes it's better to be able to spend a little bit more in the initial phase, trying to convince the donor, so that to avoid problem in the future, which have cost implication. So, for example, this is a solution for, as you can see, this is a community. And this settlement is kind of sophisticated. There were kind of a lot of resources. And as you can see how high is the community, okay? And actually, this is a community, but we have stepped kind of community, because the slope was kind of important, the gradient. And so we have decided to go for using these cement bricks, I mean, to make the edges of these communities and as strong as possible. How long will it last? Who never knows. Also depends on the people, the behavior of the people over there. But in this case, we could afford to do it. Okay, guys, I just continue unless there are any other questions. Okay, whooped up. And then we go to blocks, which are an organized group of communities. Again, don't take this drawing like the standard, something that you have to copy and paste. Please don't do that. You have to develop your own family plot. You have to develop your own community block if it's necessary. Okay, but this is to say that, for example, over here, with the more or less dimension of the previous one, we have put just 16 tents. And there are some family facilities for the shelters. I mean, they have family latrines and toilets. They have a communal kitchen, and they have 2 water points connected to just 1 water tank. Okay, so to make a kind of easier the life of the people over here. And then in every block, you have kind of open spaces, and you have a space in which is in this case was for education. And this is a photo which is illustrated when the settlement of your community is still under construction, while many communities are already occupied. This is something that you might consider in your design, how to cope to the fact that you have a major influx of people. You have to accommodate them, but you are still making the construction of the camp. How do we do that? Anything you might think about? Guys, you have any idea?
If there are already people there, we can start building from the other side and move them gradually until we reach their own side.
Yeah. I mean, the answer,
yeah,
absolutely, yes. I mean, the answer are not rocket science. I mean, it's just to use good common sense, practicality. So, but you have to take in consideration, for example, the internal road dimensioning and planning scheme of the intervention, from where to start, where we go. We accommodate the first bunch of people, and then we start to work in the other side of the settlement. And then you have to be sure that you have essential community facilities ready, of course. And then we will go to the concept of the sanitary corridor that I will speak later. It might be necessary a fencing. And also here, it's very important, the community involvement. Okay, because when this is happening, the community can do a lot. Particularly, do not ruin.
Cash for work.
Yeah, that might be an option as well. If we can engage with the community, why not? It's always a good idea, if it's possible, if it's feasible, to involve the residents in the construction of their own settlement. Okay, this is very important. Normally, with IDPs, it's possible because the local authorities are okay with it. So you can have a cash kind of intervention, cash for work, and you can pay them. With refugees, is a completely different story, because very often authorities do not allow the international community to give money direct to the beneficiary for the construction of the camps, because this is a job that can be paid, and as such should have an effect on the hosting population rather than on the refugee population. But it's definitely a good point. Community involvement is very important. By the way, what we can also notice by looking at this photo, just quickly, what do you see? What do you see?
I think it is. It will be dangerous because the heavy machine inside the camps, and maybe there is a children, and there is no safety measures have been taken during this construction, and maybe it's very important to alarm the beneficiary living in the tents to be careful. Yeah.
Yeah, absolutely. I totally agree with you. So that sometimes fencing is necessary. So you have to confine the area, so you're pretty sure that no one is going there. But fencing has a cost implication. That's why the community involvement is an essential element to enable to do this one. Here in particular is the lighting for communal latrines. You have tower lights over here. So always in these phases, even if it's under construction, always keep in mind protection consideration. In this case, it was important to give lights at night, so the families, women and children, were kind of more safely able to go to the temporary latrines. Okay, very important, every single protection aspect. This is an IDP camp, which was again designed for Iraq operation. This is a fairly big camp. As you can see, we have 20,000 individuals, and I want you to, because of the major influx, we have decided to accommodate 4,500 individuals in rabbles, in communal, in shared shelter. This is never the best option, but if you don't have space, if you are in a very dire emergency, you might go for it. I just go quickly, guys. This is also important, and that despite this is such very organized settlement, it's important to notice how a single seasonal stream has somehow shaped the big settlement. So we have not ignored these seasonal streams over here, okay? And actually, we have taken it a chance to create a more kind of pleased environment, starting from a kind of shared communal space all along the way, with some greening all around and with some nice bridges and culverts. You get the point. And this somehow shape your settlement over here. So also to minimize the impact, because normally emergency settlements look like military camps too often. And
sorry to interrupt. It's strange. The stream seems to stop or to start just from this point. What is the continuation of the stream?
Yeah. It was literally starting more or less over here. Okay. So we took use of it, because we were using also to get rid of the storm water. It was very useful, and the slope was going towards north. Okay, but please, even a single element like this one can give you some indication how to design a camp, and taking the advantage of these streams can save you a lot of money. Now here you can see the rubbles, I mean, a little bit closer, that you have the community with all the blocks with the communities, and here over here the rubbles, and you have all the other spaces that you might need for storing, for education, for camp management. Over here there was also the police and so on. And then I have a question for you guys, but it's an open question. It doesn't have an answer, but why do we usually design rectangular shaped communities? Is there a reason why we don't do that on a circular one, or an oval one, or the shape like a heart? We always go to rectangular shaped communities. Any thoughts?
I don't know. Maybe because it was very easy to identify the sites or to calculate the area. I don't know.
That's correct. It's absolutely a good answer. Very good, Khalil, because it makes our job easier. Any other thought?
I think to get use to use every single area in like, for example, in the cylinder shape, you might have not used areas. So to get use of every single area that we may have.
Yes, this is also a good point. One, having rectangular shapes allowed us to make the best use of any possible pocket of land, so you don't have a leftover, which might be the case if you use different kind of shape, like a circle. So how can you put together the circles? But I can tell you that I will show you some, some design that are trying to make something a little bit different without wasting any space. Because this is correct. Because rectangular shapes is more easy to handle for the designing phase and also for the construction phase. Here you see the construction of IDP camps. The land is pretty flat over here. Is pretty flat, and we could count, but the emergency was very, very, very strong. We were receiving 1,000 people per day, so we had to set up an emergency settlement very quickly. And having so many machines and equipment working simultaneously, if you do a complicated grid, a kind of more architectural mesh, the people on the ground will start to complain. They will say it's not efficient. So you might have a lot of resistance. That's why we stick to rectangular, because it's easier, make easier the entire process. But there is no any other reason, because we might explore different kind of shapes, and there might be a reason to do that, even cultural reasons behind, depends on the community. So here you have an overview of a camp, where actually you can see the sectors of this camp, because here you have the community over here, you have basically the blocks, and every one of them is considered like a sector. This is a pretty big IDP camp, which was done. Again, as you can see, it's pretty regular, but basically that's the way it is. I just continue a little bit quickly because we are running out of time. This is just an overview of an IDP camps, where you can have here. We try to give very to take care of the drainage system, having already a cement made system with the power network over here, so the people, they have their own light, they have their own facilities, and they can use equipment over here. This is another IDP settlement, which was needed to be built kind of quickly. As you can see here the community, you can see the sector, and actually I would like to have the attention. This has been done with the software that we were showing to you. This one over, oops, sorry. This is over here. Those are the streams which were calculated by the software. Okay, so according to the watersheds and the contour lines gotten with the global mapper, you see here, and actually you can see that those are fairly precise with the one that were actually in the ground over here. This is a clearly visible, a natural, a seasonal streams over here. Here as well. This one as well. The actual path is this one you see here, but the one calculated by the software was kind of accurate, while this one over here was not, because the actual path of the stream was this one. This is to say that the analysis that you do help you kind of very efficiently to design the settlement over here. For example, this is the settlement. There was a mudslide prone area, which was this one, and we didn't use it for the settlement itself. As you can see, this settlement has been designed having the environment a little bit taken in consideration, while the green one was an IDP camps made by directly by the local authorities, and those are just rectangular shapes placed on the ground, so without basically taking consideration any element on the ground, which is something that we try to avoid in designing these camps. And this is a different kind of community for different needs. The community is very big. The plot for each family is, as you can see, is very big. This is 10 meters times 15 meters. But here there's a completely different scenario. There was the need to have the gardening, because there was a necessary self-sustaining activity for each family. Okay, I just go quickly. I want to introduce with you the concept of the sanitary corridor, which is a linear element of planning for the setting up of the earliest wash intervention, particularly during a dire emergency with a major influx of IDP. So within this community, of course, you have your family plot, but you don't have time to build a family facility, family toilet. So you go for a sanitary corridor, which is a corridor in which you literally build all the communal facility that they need on the initial phase. Over here, we have the garbage pit, we have males and females toilet and shower, and possibly some other facilities. But I mean, thinking about the sanitary corridor, about this element, particularly an initial phase, it might be a point. Definitely might be a point. Sometimes this is kind of necessary. You cannot skip in taking into consideration. In fact, over here, you see the community. It is supposed to be in this final shape, which is there is a communal space in the middle over here, but you have a LD child development centers, you have a water distribution point, you have a workshop, you see firefighting shelter, which was a place where the people can collect immediately tools for firefighting and fire mitigation. And then of course, there is the community involvement. There is the solar street lights, and those were the sanitary corridors that eventually are dismantled when you manage to launch and to build up the communal facilities for the families, water and sanitation facilities. Sorry for running, but I'm still in space for Andrea. And this is another settlement with the erratic sector due to the morphology of the soil. So even in a situation like this one, where you have a lot of constraints because of the morphology on ground, you can manage to put communities and to create sectors like this one. So of course, I already show you this example. You have to put a lot of effort in for the design, for the survey. Definitely very important. Lastly, keep in mind that shaping a settlement module is a standardized and a consolidatory planning method, which simplifies particularly the construction phase and the organization of the settlement. But it's not an end. I mean, it's not a must. You get my point. So very often we have to go for it because it's necessary. There is no other option. But keep thinking different modalities, different kind of modules, different kind of elements. Okay, this is it for now. Thanks for, I had to run. I'm sorry for that. If you have any question, go for it. Okay.
Yeah, I have a question for the public services. As I understood from the most of the layout presented in this, it is preferable to be at the middle, at the center. So you will give all the IDPs I can say, equitable access to the services. Is that correct?
Yes, it's definitely a point. That's definitely a point. There is no, defined rule for this one. It really depends on the shape of your settlement. But definitely, in principle, also as per the standards, you have to ensure that all the inhabitants of the settlement has easy access to the infrastructure they need. So you cannot put people on the corner without the infrastructures and others in the center of the settlements with all the infrastructure around. So this must be a equity balance for this.
Maybe I can intervene on that. If you put your, let's say, emergency sanitation in the middle of the community, it is also better in terms of protection, because the community, it has to be considered like a big family, and the community itself look after the toilets and look after the showers. And if there's something happen, it happens in between the community, so there is a better control. If you put the sanitation outside, there is less control and it's more danger for girls and for maintenance.
Yeah, that's correct. And even we need to take in our consideration the sensitivity of the gender, because you know the latrines for women, and if you put latrines for women and latrines for male in the same location, it will be sensitive for the women or girls to use the latrine. And if you put them in the public space or in the center, it will be foreseen from the others side. All of them can look, these women come to the latrine. I think we need to look to the culture. We need to discuss with the beneficiary what is the best for them, and always it is preferable if there is a fence, maybe give them more protection, so you can put your facility in safe area and in lighted area as well. Yeah.
Okay, excellent. Okay, guys, I think we can take literally no more than 5 minutes break, and we come back here at 11, in 5 minutes time, basically, 5 minutes time. Is that okay?
Okay, thanks.
Excellent, 5 minutes, 5 minutes. Khalil and Khaled, are you back?
For me, yes, I'm with you.
Okay. Muhammad is still drinking the coffee. Oh my goodness! Okay, I think we have to start. I share again. Muhammad, you're back. Okay, I start sharing my screen again. Um, I just want to make a quick intro on what Andrea is going to talk about today, which is flooding. Okay, it seems that even for the Idlib operation, flooding is definitely an issue. So Andrea is going to show you how to make a flooding simulation analysis with the software that we have been discussing so far. There is no point to say how much important to avoid the flooding in the camp. We have the fire, but we have the flooding, which can be as dangerous as sometimes as a fire, unfortunately. And as you can see, just a couple of photos. This one is an IDP camp in Syria, and this is a refugee camp in Africa, where they had the chance to work on it. Basically, with Andrea, what you are gonna look how to create according to the morphology of the ground, how to make a flood simulation analysis by increasing basically the water table of the water over there, and to see whether your communities and plots will be flooded. I just want to open a window that, particularly for technician, you might find interesting. There is now there is an ongoing practice and science which is called SDS, which is Sustainable Drainage System, and WSUD, which is Water Sensitive Urban Design. You might find a lot of materials on this one on the internet, particularly for the technicians in the long perspective of the camps. And you have the presentation, so you have the link. You might start to have a look at those, because it's a different mindset when we design settlements. This has been thought for, particularly for urban areas, but it applies perfectly for the emergency settlements. In your documentation, you have also a document on permaculture, which is somehow linked with this one, and just have a look. I think this is it for my side. Sorry for rushing. And Andrea, is all yours.
Thanks. Thanks, Giorgio. I just share the screen. Okay. First, do I share the right screen? Yes. I wanted to show, I will now show you the workflow of a simulation of flooding analysis. I wanted to do it for a Syria camp in Atma camp, and thanks Colin for sharing the boundary of this camp. But when I did the try, it was not that good. That's why finally I went to the Giorgio's camp in Erbil, in Azam Shan camp, because you will see why now. So I'm going to be rather quick, but don't worry. First, this is going to be recorded. Additionally, by the end of the week or early next week, you will have a tutorial step by step how to make the flooding analysis. And there are actually two types of flooding. One flooding is flooding caused by a river, which increases the water level. And this type of flooding, you can actually not do a lot against that, because the river is just flooding everything what it will find. And the second type of flooding is flooding due to heavy rain, due to, let's say, insufficient drainage system. In the example that we are going to do now, you will have the chance to see both of them. We start from a very simple shape of an IDP camp. Like I told you, oops, sorry, it's an IDP camp in Iraq. And like usually at the very beginning, since we are going to transfer our shapefile into AutoCAD, you have to be sure that you work in UTM coordinate. Again, you go to Tools, you Configures, and you go to Projection, and you see now we are in the UTM zone of Syria, but Erbil, it's not like Syria, it's 38. If you don't know why Erbil is 38 north, I advise you to see my tutorial about UTM coordinate. and then you will understand why it's weird. But now at least you have the right coordinating system for your file, and you can transfer every shape file into AutoCAD for border development, and you are not mixing up the situation. So we have this site here, and we have to have a look first where it is. We go again on the online data, and we have a look on our imagery. We see our site, it's very close to the river Tigris. Giorgio, correct me if I am wrong. I was not there. So we might find,
it's an affluent of the Tigris River.
Okay.
The Tigris was not, it's another side, but it was a fairly big river.
Now we have, so we might simulate now an inundation flooding caused by the Tigris River, and as well we will see an flooding caused by the internal drain of this site. How the system works. We have to somehow give the information to the software, where is the river, and we do it in a very simple way. We just draw the river from the point where it might influence. We just do the river like that. Sorry, I just take out this one, so I will not have the snapping tool working. It's easier. This is my river. Doesn't need really to be very precise. If you work precise, it's better, but for time, okay, that's my river. I call it Tigris, Tigris River. Tigris River. Okay, I have it, and everything is it's fine. I think also the coordinate. I just check. That's here. You see this layer has been created. Just check if the coordinate, the projection is correct. Because I might, yes, UTM 38, it's fine. Now I go back. Okay, now I have this, the river is there, and I have to put the elevation on that river so that I can simulate what happens when I increase the water level. But the software, this is a line, and the software is not able to give the elevation to a line, because it gives you only, it asks you only for the starting elevation and the end elevation, and for the software the line is straight. So in that case I have to convert the line in a shape, and it's easy to do that. You just select the line, okay, and then you right click on the line and you create a buffer. So this line is going to be converted in a shape. It will ask you how big is the distance of the buffer. It's not really an important value, but let's assume the Tigris is 10 meters. Giorgio, 10 meters is fine, or 20?
No, I think for that, which is not precisely the Tigris, is an affluent of the Tigris. 10 meters, I think it's okay.
Okay, 10 meters, but it's not really an important value. Oops, I have to write down Tigris, Tigris shape. Now it's no more a line, but it's a shape. In fact, now I take out this one. If I go, you see, it becomes a shape. Now the software is able to put the elevation to this one. So, and I just make it blue so that this looks more like a river. I'm sorry, it's not this one. Elevation, the area style. I make it, I fill it on color blue. So this looks a little bit more like a river. Fine, that's my river. Good, we have it. I can again cross-check with the imagery. Everything looks fine. Now, from where you take the elevation, of course, everyone knows by now, we have the digital terrain model. I repeat, and I will not stop to repeat, those digital terrain models are not precise, but it's all what we have. So we work with it. In this case, I will take the SRTM digital terrain model, but like you know, we have two types, SRTM and ASTER. It's up to you to choose which one is more realistic. In my opinion, SRTM is more realistic, But of course, knowing the site, you can judge with more criteria. I connect it again, and here I have my digital terrain model. Now it's the matter to give to this river the elevation. And the simple way to do that, you just select all the river, select, you go on it, you right click on it, you go to, I know it's a lot of comments, but don't worry, it is registered and there will be a tutorial. You go to analyze measurement, apply elevation to selected features. So now the software will take the elevation of the digital terrain model and put it on the river. From where we take the elevation? We take the elevation from the terrain model because it's displayed. It's only information available actually. Okay, now the elevation has been added to the features. One river, one feature added. Now we have the elevation. You don't see any change on the layout. But we know now that the river has an elevation. Fine, we don't need anymore at the moment the digital elevation model. Now, the big question, how many meters shall we increase the water level? The best way to do that, you go on the spot and you speak with the local population on the maybe not really with the IDPs because they are new, but here there is a village, most probably this village is very old, and they will tell you, aha, when it rains, the water will arrive up to this point. Okay, I call it max water. Okay, max water. And then you go to this village and they will tell you, water will arrive to this point. Max water. So at this point we have 2 points here, this one here and this one here. I take away this one. I know that in heavy moments the water will reach. So my task is now to increase the water level from the river up to this area and see what happens to the rest. And I want to see if my refugee site is going to be flooded or not. So let's start. In order to increase the water level, I need to display the digital terrain model. Okay, we are here. I can display the word imagery as well. So now you see the picture, but you don't see anymore the digital terrain model, but it's there. And I start to increase the water level from the river. I select the river shape in that case, select, and I start analyze, simulate water level rise and flooding. Here, I will start to elevate the water level of 1 meter. I write 1 meter here, and here 1 meter, and here increase from selected area. You see, I increase now from the river level, not from the sea level. Let's see what happens. Here again, this increase the resolution of your layout. If you decrease the number, higher resolution, it will take more time. Let's see how much it takes with this standard number. If it takes, okay, it seems like that. 1 meter. So if their water level increase 1 meter, nothing really happened. I take out my imagery just to want to see. You see, we didn't reach the 2 points. Okay, we can continue. Let's increase for another meter. Analyze, simulate water level. I increase 2 meters now, the water level. 2 meters. And here I have to write 2. I leave the rest the same. What happens? It starts to be a little bit more. Let's take out this one. But I still didn't reach my point. So in the reality, when it rains, water is higher. Put again here. Now again, I increase. Again, 3 meters. Simulate water level.
So
yes, please.
Sorry, Andrea. I think there is a delay in the process because we are still looking to 2 meter, while you reach in your speaking to 3 meter. There is a delay between what you are saying and the photo.
Okay. Okay, maybe we take out the camera so we have better connection. But can I continue now?
It's okay by me. Everything is normal.
It's normal.
It's by me too.
Yeah.
The same. I
Okay,
don't
now
face
we
any
have
problem.
we have 2 layers, 1 meter layer. We have 2 meter layer, and now we can go to 3 meter layer. Analyze water level, 3 meter, 3 meter, 3 meter. Tatam. Let's see if I reach my point. Not yet. My point. I just put the point like that. Maybe it's not really, let's say, realistic, but it's just to show you how to do the simulation. But I see even more than 3 meter, but most probably by 4 meter. But I can see my side starts to be flooded here. Let's see with 3.5 meter. 3.5, simulate water level. Sorry, 3.5, 3.5 meter. Always this has to be checked, increase from selected area. But maybe now we are at the right. Yes, here we reach the point where the people say me, but not here. Okay, maybe we can see what happens with 4. Let's see with 4 meter. Analyze, generate rise, 4 meter. 4 meter. Okay, let's assume, let's say, okay, we decide 4 meter is the, let's say, is the flooding that we are expecting at least every 5 years. Of course, this is a decision that you have to take as a site planner, but no one will be able to tell you, no, it's not 4 meter, it's 4.5. And then you can say, what do you want to consider? The flooding every year, the flooding every 5 years, or the flooding every 50 years? If you consider every 100 years, maybe it's 6 meter, and then it's much more. But now we have a very bad map, like you see. First of all, flooding is not pink, usually it's blue. And if you look here, only 2 features. Okay, we have to. No, okay, let's leave it like that. Okay, we have the flooding here. We consider 3.5 meter only this time. But now we want to consider as well the flooding inside our site, the drainage actually. We take here. So like usually, we have to make first the watershed analysis to see more or less where the drain is going to pass through. And we have also an imagery, and we can check the genuinity of our digital terrain model. Let's do it again. We display the digital terrain model, take out the river for a while, and we make the watershed analysis. 25, we'll leave it 25 meters. Let's see what happens. Tack, tack. Maybe only what is seen on the screen. So it's quicker. Okay, this is now our watershed analysis. The water drains like that. And we can check out this one. We can see if it's matched somehow with the reality. Oops. Why it's not coming anymore? Where is it? Okay. We have here, we can see here a stream. We can see here a stream. Of course, if you know the area, it's much better because you can have a real. But what you should see, you should check this simulation with the ground if it matches or not. If you see that the simulation is completely wrong, then best maybe not use it. But if you see that the simulation is somehow correct, then you can use it. Okay, but let's assume this simulation is correct. Probably here the drain goes along the road. But nevertheless, let's assume the simulation is correct. So we do the same now. We increase the internal drain of, let's say, 50 centimeter only. 50 centimeter, because it's not a river, it's just a drain. Again, the process is the same. We have our water stream, or let's say our natural drain, but it's lying. We have to convert this one in shape. Again, we select everything. Selected. We go on it. I take out the picture so it looks easier. We go on it. Maybe what we can do first, we delete first the streams that are not relevant for us. For example, this one is not relevant for us. We delete it. So it will do it quicker, but just, oops, this stream is not relevant for us. Back. Where is not relevant? This is also not really relevant. This is actually the river, so that's why everything probably is not relevant for us. Okay. So for us now, oh, I delete also I also delete like this one. Okay, and this one. Okay, now let's see. Okay, now it's fine. We have those streams only. We select the stream again, and we convert them in a shape. We select them. You right click on it. Advanced page creation option. Buffer. It's a drainage, so maybe we can put 50 centimeters only. And we call it, create a new layer. We call it drainage internal shape. Okay, I create this one. Now deselect. If you go in, you see it's a small drain, but it's a shape. Again, we have to give to this drain the elevation. We select the digital terrain model. We display the vision. We select the drain. And we right click on the drain and we go to our analyze measurement, apply elevation to selected features. Okay, now from the terrain layer. Okay, now 30 features get the elevation and we have 30 features. It's correct. So now even our drain has the elevation. Now we do a water simulation, a water flow simulation of 50 centimeters only. This needs to be selected, and this one, the rest. Okay, this is not important anymore. Analyze, simulate level rise. This time is drain float. Let's say 50 centimeters. 5. Okay. Tank. Not too much. Really small. Let's do it a little bit more. Simulate. Apparently, if there is slope enough, there shouldn't be a flooding. But let's assume 1 meter to see if something special happens. 1 meter. 1 meter. Maybe also here we have to play with this parameter. Nothing really. Only here we will have some problem on here, but okay, fine. Now, this is finished. Now we have two types of flooding. We have the flooding of the river, this one, and the flooding, internal flooding. But this looks awful. First of all, we have five elements here, and we have one element here. But we want to have one single water table. So we select both of them. You select it, and you select it. So now all the flooding is selected. You right-click on it, and you make combine. You combine this area. So you combine those areas. Okay, now we have one single flooding, which is called, it's a new layer, combine flood. Okay. Now, this you don't need anymore. This you don't need anymore. This you don't need anymore. You deselect. Okay. But you see, the shape is awful. So you make a nice shape. You select it again. And you smooth it. To smooth it, it's reshape feature. Somewhere should not. Ah, yes, smooth. You smooth it, looks much better. Select, agree with me. And now we put a nice color. It should be kind of blue. We fill it, solid fill, kind of blue because it's water. Even though usually water is brown, but for some reason we put it blue. Okay, and we make it transparent, 50%, for example, transparent. Okay. Ta-ta. Now we have the flooding. Now you can start to make your map. You see? Now you can say, and you will put our point. What is the point? Drain, water source, drainage internal, drainage source, here, max. Okay, we have our point. So you see the flooding analysis, increasing the water level of the river of 3.5 meters, and the internal drain of 1 meter, you will have problem in this area. All this side is going to be flooded. Here we have problem apparently as well here, but the internal drainage is, you have to be very carefully because the site exists, drainage has been already developed. So this should be, this is a simulation if without any man-made drain, okay? But, you know, you understand that for sure. No. And then all this shape can be, of course, exported into AutoCAD, and you can further elaborate your maps. It was quick, but and probably many steps, but you can see that the result is good, and it's very visual. And with this map, you can present it to the authority, to whatever people are interested to, and it helps a lot to understand the situation. This is very important to do before you develop a refugee site. And additionally, again, I want to repeat, if your digital terrain model is of a bad quality, the simulation is very bad. It means before doing that, you should go there with the total station, do a nice digital terrain model. Actually, this is a tutorial how to do a digital terrain model with the total station. If you cannot do it with the total station, you can do it with a drone. During the next week, you will get a tutorial and probably a presentation on how to make a digital terrain model with the drone. But with this precise digital terrain model, you will have a precise flooding analysis. I was actually much more quicker than I was expecting, but I leave the words to you now. If there is question or whatever, or impression.
Yes, Adrian.
Yes.
Can you hear me? I think I have a problem with the internet connection, but I have a question.
Tell me.
Can you hear me?
Yes, I can hear you well.
How we can get benefit from Earth Explorer, especially for satellite information, Landsat 7, it is free. I know the other Landsat, it is need to pay for any information you need to it, but for like this modeling, I like information about the soil, about the streams, about the elevation model, accuracy, resolution, a lot of information like this site provided. How we can use the free satellite information
I mean,
in our, yeah.
satellite image, you can have many. You have Bing, you have Google Earth, you have many satellite image in and I don't know what to tell you about how you just browse in the internet, but mainly Bing and Google Earth is good enough to have an idea about the soil. And based on my information, the only two available digital terrain model is SRTM and Aster. And if you want to know about the precision of those two digital terrain models, you have to go on the website of this provider. You just Google Aster digital terrain model, and they will tell you exactly how they do it, how is the precision and everything. But
yeah, what I meant, it is a lot of information like now satellite provided to us. It will be related to the accuracy, how we can get benefit from this modern modality or technique use that the other used.
to be honest, I don't understand the question. I mean, how? You have it, you just display it, and then you get the benefit out of it.
No, I think it's not easy to get like this. For example, what you did now, floods.
Yes.
You know, I think for floods and modeling, I think there is more accuracy by using available satellite information.
Yeah, what
I'm talking about Landsat 7. It is a free, and you can how we can link between what this satellite provided to us information and what this global mapper provide to us, and do like a comparison between this and go with the most accuracy one.
Okay, now I have to investigate how for sure, if Landsat is free, like you say, you can download it and display it in the Global Mapper. But I don't know how to download Landsat, and I don't know the resolution of Landsat, but I can investigate, and then I will be able to answer the question. But if you have access to Landsat imagery, just download it on your computer and open it in Global Mapper, and then you have it. Global Mapper will open almost all imagery that you can imagine. It's very powerful. Just download it from Landsat. But I will have a look later during the weekend, and then I might come back to you if I find something interesting.
Oh, Khaled, if I can, Andrea, if I can add something.
Yes, please.
I mean, specifically, I don't get mad into get the most updated satellite imagery. Normally, what you can process with this kind of information that you get using simply Global Mapper or Quantum GIS for your job might be enough. But the point is you have always to cross-check in the field whether this simulation might be accurate. Andrea, at the beginning of his presentation, was introducing the idea to have some geo-referenced points, which means you go to the field, you speak with the hosting community, and you ask them to indicate on the ground the position where the water reached, for example, the last winter. So you take the point. So as Andrea was doing, was rising the water table until to get to the point, and you have an idea more or less of the behavior of the water also in other parts of the settlements. If you don't have anyone to speak with, because in this particular case here, over here, that I made the water flooding analysis, unfortunately, there was no one around, because all these villages over here were empty because of the war. So there was no one around to ask. But basically, you go around, you walk, you try to capture and to see signals on the ground. For example, you might see trees that they have a different colors of the trunk, because the lowest part is darker than the higher part. So that your eyes are probably the last winter, the water get to that point. So you have to seek for all the signals on the ground, and also if you have the chance to speak with the local population to get an idea where is the edge of the water when the rain comes. So, and then is always a projection. You cannot be 100% sure. For example, in Africa, we completely missed the actual behavior of the flooding during the rainy season. We were hoping that our simulation were kind of accurate, but when the flooding arrived, when the rainy season arrived, it was a completely mess because we had camps with that were completely flooded. So it's always a balance between your personal experience, the data that you see, what you can visualize on the ground. It's a combination of all of them. Over.
Yes, and
Thanks, George. It was very clear. Yeah, it was very clear. Yeah, thanks. Actually, I just since we are working remotely, and maybe sometimes we need to quickly get an idea about the location, the floods, and the very important issue here now when we discuss like this design or do like this simulation, we need to talk about the mitigation that we need to take, what we can do to protect or secure these camps. So if there is any session about what we can do, what type of construction we can go through, that's very important for us, maybe because at the end we need to provide the cost, we need to the BOQ, and we need to reach the field and to see applicability to do like this.
Exactly, and this flood simulation will show you where are the weakest point. In this case, for example, it is very clear that the weakest point is on the south, where you have seen the site is flooded. And it means there you need most probably to make some barrier, to do something to protect this area. And the rest of the site seems to be somehow okay. And but the simulation helps you to identify the weak point, and then based on that, you can start to develop the recommendation or the protection measures.
Yeah, Andrea, can I show you this? Can you stop sharing
I just
your
want
screen?
to tell you something. Again, I repeat for the 10th time, the quality of digital terrain model is essential. In such a case, you have an area that is more or less between 4 to 9 square kilometers. And such an area can be mapped very easily with a drone, a classical DJI drone. In 4 flights, you can map 4 square kilometers, and you would receive, in this case, a precise digital terrain model. That's why I think it's time for all this organization to think about the use of drone, if possible. Yes, now I give you the screen back to you, Giorgio.
Okay, so very quickly, I just share again because I think I missed to give you this in the floating intro. Andrea, what you were asking, it's very important. I mean, the science of the water mitigation measure is a real science, and you need to have in your team, if it's possible, if they are available, specialized professionals. I mean, just to be practically speaking, a site planner you cannot expect as a supplier, or a site planner, to have any possible knowledge that you may need, particularly for complex settlements. Is a team effort, the design. So you need someone who's really specialized in this kind of issue. And I think this is definitely important, particularly when you have to go to mitigation measure in case it happens. It shouldn't be happening, but it might happen. But I just want to show you the last this one. Okay, we have to rely on our drainage systems and our drainage network, and is an element of the designing of every settlement, which is fundamental, guys. I will never insist enough. Again, I've seen drawings in which the drainage system was barely indicated, like in a single line, without having a clear idea the direction where the water is coming from and where you precisely get rid of it. So, the drainage system can significantly contribute to sustainable development and to improve the place and the spaces where the people live in, work and play, blah, blah, blah. So, and we have to put a dedicated effort. And then we go back again to the survey that you have. Of course, we can rely on satellite imaging, but if you can combine those with an accurate total station survey or a drone survey, this is the best option that you have. And also keep in mind that
just to interrupt you, if you do any construction work in terms of mitigation for flooding, you need to have a precise survey. You cannot rely on digital terrain model of internet. Of course, as soon as you do a drainage or a retaining wall, you need to be precise. You agree with me, right?
Yes, I do agree. And remember that the very first step that any site planner can do to prevent flooding is site selection. To select the good site. There is no any other way. So your judgment in say this place is good, it's fundamental, because I mean, trying to top up problems created by flooding because the site was not the best option is always a nightmare and extremely costly. That's why many emergency settlements get flooded, because there are no the resources to make an interventions. And then we have to rely on the capacity of the people to react to the issue. The point is, too often in our job as a site planners, we are not free to choose the best site. We have to get what it has been given to us.
And on that note, yes, we are not free to choose the site, but with this tool, even in a very superficial way, we can show a paper, we can show a map, and we can tell to the authority, to the concerned people, this area is going to be flooded. Without these tools, it will be very difficult to convince the authority that the place is not indicated for refugees. To you, Giorgio.
Okay, guys, how are you?
Fine, Giorgio. I do have a question. Today I was more listening than speaking. I had a question for the you know, this flood mitigation measure. When we, as for example, in the AutoCAD Civil 3D, there is something called basing catch point, where you can refer to a point and all the flows could be discharged to that point. I am asking Mr. Andre if it, I am wondering if this opportunity is available in
I think it's, yes, it is available.
Global Mapper. Yeah.
It is, Giorgio, I can show to,
What
if I understand properly, I can show you it on the screen.
Yes, please.
Just take back my screen. Which one is it? Okay. Let's go back to take out this one. Drain, float, one, no, drain. Okay, let's go back. No, where is the watershed? Let's go back to this one and to this one. You have to, when you do a watershed analysis, you have options. Generate control watershed. Just I put 1 point. I put 1 point just for the exercise. I put 1 point here. I call it arrival. Okay, I have new side, new arrival. Okay, okay, and I put 1 point here. I call it departure. Sure. Sure. Okay. Now I have 2 points. Now what I can do with this flooding analysis, I can tell Global Mapper to show me what kind of the water, from where comes the water. If I have this point here, from where comes the water, arrives the water to this point. So what I have to do, I just have to select arrival, select arrival. You see, it's selected. I can take out the picture so that it's easier. And then I go to analyze watershed. Keep it like that. Arrival. And then here, trace flow. Trace from selected line. And now only from. Let me see. Create watershed. No, trace from noise. Not. I'm sorry, I was mistaken. You can do it only from the departure, not from the arrival. So
I could read something related to receiving water or collecting
you
water.
could read.
Yeah.
Generate watershed. Count.
Yeah, the fourth one, create watershed areas showing drainage to selected points. Yeah, this one.
This one. Okay, let's.
Isn't it?
Let's see if it could
I don't know. You are the expert here.
but yeah, not that much. Arrival. I mean, I know I forget arrival. Okay, let's see what happens. Okay, now it's departing from this point, and it shows you the way. Let's do it again. Watershed. Count. Trace from selected lines. Trace from selected point. No. Create watershed to selected point. Let's see. To selected point. Let me see if I split what is inside. Create split. Nothing. It's just the watershed for this point. Okay. And now because now it's clear. The thing is that we didn't. The watershed area was too small. Now we have this point arrival here, and now we increase the watershed area, and then we have it. Analyze watershed arrival, but we have, let's say, 200 or 100, and then you put 100, and then it should be fine. Then it's still very small.
Okay, Andre, sorry for interrupting, but we are actually going out of a bit of time. Because of this, there is going to be a tutorial. Andrea will prepare a tutorial of this first water simulation, water flooding simulation. I wanted to say something which I have completely forgot, so I apologize, which was related to this.
I want to ask if it was clear what you can do with Global Mapper, or it was not clear to the people.
Yes, it was clear, Andre, but the thing which I was asking about is the collecting point for the water, not the discharging point, the water which goes out from that point. Okay, that was clear. You made it, but the first one about collecting water from all the surrounding water surrounding valleys, small valleys.
Yeah,
that was my answer.
Andrea, he was talking about the basin. You know, he was talking about the basin. You know, yeah, the basin. Yeah.
You wanted to display the water basin.
The catch point for the basin. Catch point for the basin.
Yeah, you have it. You can do that, but I just I do it very quick now. I take out this option. You go to here, watershed, and then here you have to create water area. This one. Why? Sorry, create watershed. This one. This is the option that you want. And then now it's fine. You see, now you have the basin. You see? Those are the basin, the watershed areas.
So that point, which is located in the yellow area, the water would be collected there in that point from
So
that
the
basin.
water that
Isn't it?
rains, that rains here goes down to this river, and then goes down here.
Because yeah, my question, Andre, I'm sorry for making this a little bit longer, but I have to understand this because it's the point actually where we can start our mitigation measures and solutions. Because if we assume that from that point we will collect the water because we are forced to do that, or we cannot, we don't have much space to locate our drainage systems point as inspection pits or etc. So we can assume there we want water to be collected, and from there we can discharge it to the departure point.
Here you see how water will behave if you don't do anything. And then if this channel for you is on the right position, you just can, let's say, you can increase the quality of the channel, you make pave it, you do drainage system. If you don't want the channel here because you have a hospital, you have a road or whatever,
yeah,
then you have to make a drain, you have to dig, you have to change the shape of your terrain to change the direction of the water. This is what will happen if nothing has been done on the field. You get me? But
I got it.
You can arrange it. And then once you arrange it, you can make a new digital terrain model and you can simulate again to see if your arrangement was properly planned or not.
Yeah, okay, thank you. As for example, as siphon or culvert,
establishing. You can move the location of the stream, of course, but you have to intervene, and this costs.
This is the, we have to invest the let's say the natural pathway of water. Exactly. If there is some peril, then we have to assume some solutions.
Yes. Yeah, if I might add one last point. Andrea, do you mind stop sharing the screen?
Yes.
Okay, I will share mine. Actually, okay, do you see this?
Mm-hmm.
Okay, there might be situation in which the sewage of the drainage system that you have in place maybe is working, but cannot cope with heavy rains with the specific peaks. So sometimes you might decide to identify an area that you have to secure, you have to fence normally, but this is not that much expensive. This is pretty sophisticated because you have a protecting layer which is made with this kind of fabric, and basically is an area where you can overflow the excess of water in case of heavy rain. Okay, I should have another sample.
So why do we put this layer of and why don't we let the land absorb the water?
Well, it depends case by case. I'm not a water engineer, so we'll stop here. But this is another example that, for example,
on your question, if this is a water treatment plant, maybe if you let absorb the water from the soil, there will be groundwater contamination.
Mm-hmm. Okay. So this is to go back. This is basically two kind of. I mean, digging a hole is not that expensive. So this is a kind of last resource to get rid of the water. So it's better to direct the water in this kind of quarry, which has been artificially created, so you can divert the water to here, at least to cope with heavy rains. But first of all, you have to be sure that your drainage system is existing, has been designed, has been realized. And I personally suggest always to overscale the manholes for checking and inspections, because most of the time the problem of any drainage system is get polluted, used as a dump site. and so you might have the perfect one, but which is not properly working. So those one help you sometimes to overcome the problem if you can afford. Guys, I think this is it for now. I think we should
Yes,
stop.
I just get a message from Khalil. Khalil, you speak about if there is chance of a course about drone. Yes, there is. My contract with IOM and the cluster will stay for 5 more months. And after this workshop, if there is interest, remotely we can have a drone course. It takes maybe several sessions, but if there is interest, we can do that. And I don't know if there is a chance to have it in Syria, but I know there are NGOs using it in Syria. Probably once you have the drone inside, you can use it. I don't know if if I answered your question. Khalil.
Okay, guys. Are you okay? Are you alive?
Yes.
Okay. We will have the same session this afternoon. In case someone wants to repeat it, you are most welcome.
No, I don't think you will, because otherwise you will kill yourself after that.
Okay, thank you for your time.
Okay, thank you guys. See you next.